What's going on, guys? It's Mr. Jones once again. As you know, I am back. So we're going to do a little bit of review first. As you can see on the screen, there should be some familiar things to you. So first things first, make sure you guys get out your notes. Pause me if you need to. But I'm going to give you some really good notes today that you're going to need for the rest of the quadratic session. So go ahead and pause me if necessary. All right, hopefully you've had a chance to grab your notes. Really quick, we are going to talk about standard form. So standard form, if you remember, looks just like this. It has a quadratic term with an x squared, then a linear term with an x, and then a constant term. It's just a number. Okay, so if you remember, A, B, and C are all where numbers go. Now, quadratics is what we are talking about. With all these different forms we're going to learn, there's only three, don't freak out, but with all of them, we're talking about quadratics. And so let's remember really quick, what does it take to be a quadratic? X squared, let's actually use a different color here, we'll use orange. X squared is my highest power. Remember, that has to be true. Highest power when we are fully simplified. So I think that's pretty important. So what do I mean by that? If you have a whole bunch of x squareds or x's and you can combine like terms and simplify, then you don't really know what kind of equation you have. But if you only have one of each term, just like this, and we're completely simplified, and x squared is your highest power, then we know we're dealing with a quadratic. All right, so now what this new task that we did right before I left for a while was we were supposed to discover vertex form. So I know we didn't finish discovering vertex form, but you should maybe recognize A, H, and K. But either way, go ahead and write vertex form, please, in your notes, just like this. And we're going to label A, H, and K, and we're going to talk about what those letters did to our graph. So go ahead and take a second to put this in your notes and leave some room for some more notes. Make sure you pause me to do that. All right, so if you guys remember before, we went into Desmos and we tested a whole bunch of things out, and you were able to see, like, okay, what did K do to my graph? What did H do to my graph, and so forth. And so here's some examples of what we talked about. And then we're going to go back to the whiteboard, and we're going to be able to plug in for the equation. So here we go. Here's my parent function. Remember, we talked about a parent function being the simplest of all equations. You can see it over here as y equals x squared. So I don't have to put y equals, but let's go ahead and put it anyway. So there's my parent function, and my vertex is right there at 0, 0. So the very first thing is, hey, what happens if we add a plus k at the end? So look at this equation right here. Any value for k, what is that k going to do? So we put a plus 2, and it looks like the graph just went up, right? Remember, our original vertex was here, and now my vertex is here, so it went up 2. And then the next one, let's say if I put a minus 1, what happens if we put a minus 1? So there it is, it went down 1. So it seems like whatever k is made the graph go up or down, right? So let's go ahead and leave those up there, but we're going to go ahead and click this, and you'll see this cool little slider comes up. And see what happens as k changes between -2 and 4, since those are the numbers that are visible. So check this out. As k gets bigger, my graph shifts up. As k gets smaller, my graph shifts down, and if k is negative, my graph goes down below the x-axis. And that's a pretty cool way to prove that any value for k makes your graph shift up or down. So with that being said, let's come over here to the whiteboard/green board, and let's go ahead and put in what we say that k is. So k is purple. Just put some arrows here. K. That is my vertical shift. Okay, k is my vertical shift. This basically means that we're going to go up or down. So if you don't know what vertical shift means, it means up or down. Okay, so the graph goes up or down k units. So make sure you put that in your notes because that's very important. If your graph is normally sitting at 0, 0, which it always is, then k makes it go up or down from that point. All right, so let's go ahead and check out the next letter now, which is H. All right, so once again, you always go back to your parent function. And we look at that first. So we say, okay, what if we make this the equation, x plus 2 squared? Remember, h is where this number is right here. So what happens if we put a plus 2 in here? What does it make our graph do? Ooh, that's weird. It went to the left. You would assume that it goes the other way, right? I wonder if this next one goes to the right 3. Oh, look, it sure does. So there's a couple examples of what putting in numbers there do to the graph. It looks like it shifts it side to side. So I'm going to go ahead and put this. I didn't change the numbers this time, but let's go ahead and do the sliders. We're starting at 0. It goes really fast. As my h values go, see, left and right. Now this is going to be a little bit more confusing. So we'll have to talk about later because it looks like in the slider that as h gets big, I go to the right, and as h gets small, we go to the left. But we just realized that whenever we plug in a minus 3 here, I go to the right. And if we plug in a plus 2, we go to the left. So why is the slider different? Let's talk about that. All right, so I want you to look at this equation and realize that it says x minus h. Okay, h is the only thing that changes there, not the minus sign. So whatever h actually is, let's pretend, see, we have x minus h, so let's pretend that h is 4. If you plug in a 4, a positive 4, now it looks like that, right? If you already have an x minus, now if h is negative, let's say negative 3, let's plug in a negative 3. Well, where does that actually look like? Well, it looks like this, right? So the value of h that you actually plugged in is opposite of whatever it ends up looking like, which makes it actually really confusing. So we'll talk about that more. But I didn't want the people that were looking at that to be all weirded out. So with that being said, h is not my vertical shift. That's up and down. The word for this one is horizontal shift. And that means side to side, right? Or left and right. I guess I should have written that instead. Let's write that. Left or right. Oop. Left and right. Now, I always like to, if I can spell, I always like to also say that this is the opposite. This shifts opposite the way of the sign. So I'm going to put here in red. That's a little, actually red's not what I'm going to use. I'm going to use pink. I'm going to put a little asterisk here. Opposite of sign. So you would think that if it says minus 4, that it would shift to the left, but it really shifts to the right. So you can give yourself an example here if you want and say x minus 2 squared is a shift 2 to the right. So this is like an extra little bonus note here. This is an example. So an example of that, right? Let's erase all this shenanigans. One sec. All right, so now that we have those two letters down, the very last one is A. So let's talk about A. There was actually two things to do with A. It was actually the same thing as K and H, but it actually has two different effects, kind of. So let's check that out. All right, so let's talk about changing the A value. So I have my parent function already sitting there, so you can compare it to the normal function. But I think it said, let's say that what if we put a negative sign in the front? I think that was the next question. what if we put a negative sign in the front? What does that do? So we tested it, and it literally just flipped the graph upside down. Okay, so making a negative, whatever it is in the very front, should just flip your graph upside down, just like this. Okay, so it was right side up, now it's upside down. Now, what if we put in a number for a, right? So a number in front. So now instead of having x squared, we put 2x squared. What happens there? Ooh, so the vertex is in the exact same spot, but the graph looks to be skinnier, just more stretched out. Let's add a different number, like a 5. How is that different? Ooh, the 5 is even skinnier than the 2. So it looks like the bigger the number we choose, the skinnier the graph's going to look. So let's check it out if we use negatives and positives, what happens. And also all the way up to 10. So here we go. Check this out, the slider. Watch the slider move. Woo! And it flipped upside down, and then as it got bigger negative numbers, it got skinnier. Check that out. All right, so the skinnier, that's neat. All right, so something that happens in there that you guys might not be noticing because it's happening too fast is there is a point where the graph gets fatter. Okay, so let's go ahead and go back to our green board really quick. And let's talk about A. Okay, I'm going to put some stuff in for A. All right, so I wrote a few things about A here, so let's go ahead and talk about them. First of all, A is called the stretch. So that's the word for what this is doing. It's actually stretching the graph upwards, but most students like to talk about it as getting skinnier. So if A is negative, then it flips the graph upside down. You can see I drew a little picture. I should have drew it better, but that's just showing that the graph's going to flip upside down. If A is greater than 1, okay, whether it's positive or negative, then the graph is skinnier. The larger the A value, the skinnier the graph. So we established all that by looking whenever we did our discovery, right? All right, so lastly, we're going to talk about how does the graph get wider? So there's the parent function in red, just like always. And we saw that putting a number in the front, such as a 2, will make the graph skinnier, right? But how do we make the graph wider? So there's one that's wider. If you guys didn't try, you can put in a fraction, like 1/2. So 1/2 x squared, or 0.5 x squared, is wider. What about wider than that? 1/5. So it looks like the smaller the fraction, the wider the graph. Let's actually test that theory. I put the A values here between 0 and 1, so it's only going to give me fractions. Okay, so let's go ahead and try that out. Oops, I can click on this first. So you can see as it gets closer to 1, I get closer to the parent function, and as I get further away from 1, it gets literally to the end to almost be a straight line. I mean, check this out. It looks like a straight line. A can't actually be 0. But there we go. 5/1000ths is a very, very wide parabola, right? So there's a very wide parabola. If we zoom out, you can actually see the shape better. Okay, so it's much wider. And then the closer we get to 1. Now, if we get past 0, then we get to the negative. So let's actually see what happens there. So here we go. You can see what happens as I get closer to 1, I get closer to the parent function, and then again closer to -1 is closer to that negative parent function. I'll put that here in purple so you can see what happens. All right, so I wrote some stuff for the A value, the last stuff. If A is greater than 0 but less than 1, aka a fraction, then the graph gets wider. The smaller the fraction, the wider the graph. So if you want to give some examples in your notes, but this is all the notes for vertex form, and then now we'll be able to do some examples. All right, so now you can see next to your vertex form notes that I've given you some examples. What I want you to do with those examples is tell me in what way did the graph shift. So how did the graph shift from the parent function? So what is the shift? So go ahead and pause me. Please pause and go ahead and write down what the shift is, and then I'll go over them. All right, so hopefully you had a chance to do these. If you didn't do them on your own, please pause, but I want to make sure you guys know what the heck we're talking about. So if you're given the equation y equals x minus 8 squared, like this first one, this is going to be a right 8 shift. My graph shifted right 8 units. Okay? Right 8. So that literally means your vertex is already sitting on the 0, 0, and your graph only moved right 8, so it doesn't move up or down. This next one right here, we went down 8. This was my K value. This was my H value, so go back and check those out. It's different because it's inside the parentheses. All right, this next one we flipped it upside down. Okay, so now my graph is going in this direction, and I went up 3. So I shifted up 3, and I flipped my graph upside down. This next one, my graph is skinnier. So skinnier. And also I went right 1 and down 6. And you can check these in Desmos if you want. If you toss these in Desmos, you can make sure I'm not full of baloney. All right, this last one's about as hard as it gets, so if you can do this one, you're good. That negative 1/3 in the front is my A value, so that makes my graph go down like this, first of all. It's fatter than normal. It goes left 4 from the normal spot and up 1. So there's 4 different things you could have put there. All right, make sure you have all this in your notes and submit them, guys. Have a good one.